Algebra 2, lesson 46, we're going to be talking about finding trigonometric functions and their reciprocals. Now, reciprocals isn't too hard. Reciprocals are we just flip it, right? But trig functions are three things: sine, cosine, and tangent. And you've got to get these three things down, okay, because you're going to use it a lot, okay? So trigonomic ratio, right, is something over something else, correct? Okay, so each trig function has a specific ratio, has a specific something over a specific something. So in a trigonomic ratio is a ratio of the lengths of any two sides of a right triangle. Okay, so all of this is based upon right triangles. A function whose rule is a trigonomic ratio is a trigonomic function. And so these three common trigonomic functions are called sine, cosine, and tangent. And you'll find that they exist on your graphing calculator here, here, and here, right? Do we see those? Okay. And because they're abbreviated as SIN for sine, COS for cosine, and TAN for tangent. But we don't pronounce it as sin, we pronounce it as sine, okay? So sine, cosine, and tangent, all right? So in trigonomic functions, the sine of an angle, and I broke this up into a lot more pictures than what your book does, because I wanted to take this one thing at a time. So if you look at page 331, you'll see that I have taken one chart and turned it into 3 slides, okay, hoping to kind of break up the information a little bit. The first thing we're going to look at is sine, okay? The sine function. Now I use the same picture for all 3. The hypotenuse is always the hypotenuse, right? It's always the side it's opposite the right angle, all right? But where opposite is dependent upon which angle I'm using, all right? So this, what we're going to talk about is from sine of angle A, meaning this angle right here. So this BC is the side that is opposite angle A. Okay, so if I want sine of angle A, I want opposite over hypotenuse. So for me, for where we are, opposite is side BC, and hypotenuse is always, in this case, AB. Okay, even if I was using sine of angle B, hypotenuse would still be AB. All right, so in terms of how can I remember that sine is the ratio of the side opposite to my angle over the side that is hypotenuse? Well, we break it into an acronym that we call SOH. S-O-H. Sine equals opposite over hypotenuse. And because we use this so much and need to use it a lot, right, I'm going to do a little call and repeat here this morning. I know this feels like little kid stuff, but I need you to get to where we know this. So whenever I ask you what is sine, you're going to say opposite over hypotenuse. So what is sine? Opposite over hypotenuse. Okay. Now, are we familiar enough to be able to identify a side that is opposite of an angle? Yes or no? Okay, we got that down. Because can we identify the hypotenuse of any triangle? Of any right triangle? Can we identify the hypotenuse? Okay. And now we know how to identify the side that's opposite of an angle. Because the next one is the one that people really have trouble with, all right, which is adjacent. Okay? The side adjacent is the side that is not opposite and is not the hypotenuse, right? It shares a vertex, or it shares a vertex, touches the vertex of my angle, and is not the hypotenuse side. Okay? Does that make sense? So side AC is adjacent to angle A, but it's opposite to angle B. So if I was looking for sine of angle B, I would get AC over AB. That is sine B. Does that make sense? Because this side is opposite to angle B. Sine is always what? Opposite. Okay, let's try it again. What is sine, class? Let's try it again, but we're going to include Angeli this time. What is sine, class? There we go. Okay. But that's not the only trig function that we have. right? The next trig function is cosine. Cosine, we abbreviate as ca. So, ca. Now, if you were in Boston, you would drive one of these, because they drive the cars around. They park the car in Harvard Yard, all right? So, no? All right. CAH. Cosine of an angle is the ratio of the length of the adjacent side to the length of the hypotenuse. So we haven't changed the triangle at all, but if I was looking for cosine of angle A, right, from here, right, I want the side that is adjacent over the side that is hypotenuse. So the cosine, what's neat about this is that the cosine of angle A is the same ratio as the sine of angle B. Confusing. Maybe I need to just be quiet. Don't include that. Okay? This cosine of angle A is adjacent over hypotenuse. Adjacent over hypotenuse is cosine. Class, what is cosine? Adjacent over hypotenuse. Now, if you don't want to take part in the little kid call and repeat, that's fine, but make sure that you get it. Okay? Make sure that you know it when you need it, so that it's adjacent over hypotenuse, and that you know how to find the adjacent side. Okay? Because it's that ratio. If I was looking for the cosine, let's see how well you can do this. Let's say we wanted cosine B. Cosine B. What is the side that is adjacent to angle B? BC. What is the hypotenuse? AB. All right, good. So if I wanted a cosine of angle B, I would find the side length of BC and put it over the length of the hypotenuse. Okay? And that would be my ratio. Any problems so far? Okay, we get this. All right. So class, what is cosine?
Adjacent over hypotenuse.
And what was sine?
Opposite over hypotenuse.
Opposite over hypotenuse. So, ca. Okay, so, ca. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. All right, and the next one, tangent. Tangent is opposite over adjacent. So, from angle A, what side is opposite to angle A? BC. And what side is adjacent to angle A? AC. Well, what if we went to cosine of angle B? What is opposite of angle B? And what is adjacent to angle B? All right, so I would get AC over BC. Okay, does that make sense? Class, what is tangent? And what was sine? And what was cosine? Okay, do we know how to find the side that's opposite? Do we know how to find the side that's adjacent? All right, and do we know how to find the hypotenuse? All right, does this seem pretty easy so far? Okay, kind of, maybe-ish. Okay? All right, so to determine the sine, the cosine, and the tangent functions for angle B in the diagram, we've already talked to this. Be sure that we use AC for the length of the opposite side and BC for the length of the adjacent side. The trigonomic functions are only used for the two acute angles. We never use, the sine, cosine, or tangent of the right angle, ever. Okay? Notice how we never talked about angle C, because it's the right angle. And here's the problem anyway, is that what is the side that's opposite to the right angle? So I'd end up with the hypotenuse over the hypotenuse, right? Which is going to be 1, right? So it has no point. It does not make sense to find the sine, cosine, or tangent of angle C or any right angle. Okay? We will never do that. The three other trigonomic functions are called these. These are functions that are not in your calculator. They are called cosecant, secant, and cotangent. They are abbreviated in order: CSC for cosecant, SEC for secant, and COT for cotangent. Now, we are covering this, or just recently covered this in Algebra 3. So if you ever plan on taking Algebra 3, it's nice to have learned this. Okay? Because we're going to go back over it there. They are the reciprocals of sine, cosine, and the tangent functions. What does it mean to find the reciprocal of a ratio? We just flip the numerator and denominator, okay? So if sine is opposite over hypotenuse, what is the reciprocal to sine? Hypotenuse over opposite, okay? So if cosine is adjacent over hypotenuse, what is the reciprocal to that? Okay, I'm getting one person that can answer these. If tangent is opposite over adjacent, what is the reciprocal to that? Adjacent over opposite. Okay, so all we're doing is we're flipping those. Okay, now here's the thing. Cosecant is the reciprocal to sine. All right, so if it says find the cosecant of angle A, we're going to use sine and flip it. All right, so the cosecant of angle A is hypotenuse over opposite. Okay, cosecant and sine are reciprocals. So you'll have to remember that. Okay, the reciprocal to cosine is secant. So secant is hypotenuse over adjacent. Okay, now the easy one is cotangent because it's just reciprocal to tangent. So I can remember tangent, cotangent are reciprocals. Okay, so cotangent is adjacent over opposite. Okay, if you can remember your three main trig functions, right? Sine is what? Opposite over, okay, opposite over hypotenuse. Cosine was what? Adjacent over hypotenuse. And tangent was opposite over adjacent. Then I should be okay. All right? Let me go back just kind of to a blank page here. All right? So somewhere I'm going to write, sine is to cosecant. Okay, cosine is to secant, and tangent is to cotangent. Now, if you're asking how do you remember which one is reciprocal to which, the easy one is this and this, right? Okay, that one, no problem. The confusing one is sine to cosecant because it's S to C. Right? If I basically start with three letters, I start with S, C, and T, right? Through the whole thing. So, as challenging as it may be, S is to C, and C is to S. Okay? So if I can remember what my basic trig functions are, I actually remember my reciprocal trig functions by the two that make the least amount of sense. I'm going S to C and C to S, and then tangent. Okay? I don't know if that helps you or not, but any way that I can kind of help get it into my brain so that I can use it when talking to you guys is helpful to me, so I'm hoping that it's helpful to you. All right. So trigonomic ratios are related to the angle measures rather than the lengths of the sides. For instance, the ratios of a right triangle whose sides measure 3, 4, 5, like a Pythagorean triple, will be the same as those whose measures are twice as much. 6, 8, 10, still a Pythagorean triple. 9, 12, 15, still a Pythagorean triple. This is because the angle measures of similar triangles are the same, meaning that those ratios are going to reduce down, right? Because they're fractions that will reduce. So the fraction 3/4 and the fraction 9/12 is still 3/4. Does that make sense? Okay. The values of the trigonomic ratios for given angles are listed in trigonomic tables and are stored in scientific and graphing calculators. You have trig functions in your calculator. So we made it through all this, right? It's a lot of information. It's information you need to hold, maintain, keep, okay? You have your book. You have some charts in there that are helpful on page 331 and through those types of things. Okay, but opposite, adjacent, hypotenuse are terms that you need to know. Let's see if we can look at some questions here. All right. we want to find the values of the 6 trigonomic functions for theta. So we want to come from here. All right. Now, one of the things we need to go ahead and do is solve for what? We need to solve for the hypotenuse. How are we going to do that, Eric? All right. So Pythagorean theorem, right, which you've just quoted. How can I apply this to that?
I think that's the 45. No, that's just 40. 40 squared.
40? It's a 48. Okay, it's a 48. So you're saying 48 squared
Plus 14 squared.
C squared, okay. 48 squared is what, guys? What's that? 2,304. 196. We want to add those things up. What's that? 2,500. Okay, and we want to square root that. What do we get, like 50? 50. All right, so this is 50. Okay, we've got that now. All right, now we want our ratios. Let's start with sine. What was sine again? All right, so what is opposite of theta? What's opposite of it?
14.
What's hypotenuse? 50. Can we reduce that? That would be what? 7 over 25? All right, does that reduce it all? No? Okay. So far, boom, right there, right? Sine theta is 7 over 25. Now, also, it's the only one that has that as an answer, so if I was taking the ACT, would that be enough information to get me the correct answer? Yeah, but we're not taking the ACT, right? We need to make sure that we know what we're doing. What was cosine?
Opposite.
Adjacent over hypotenuse. All right, what is adjacent to angle theta? 48. What is hypotenuse? 50. Does that fraction reduce? Okay, well, I can reduce both those numbers by 2. 24 over 25. Okay, we got that. What is tangent? Opposite over adjacent. But that's important to get. If we get those mixed up, we're going to be wrong. All right, what is opposite to theta? 14. And what is adjacent to theta? 48. What does that reduce to? 7 over 24. Of course, you could probably look there and see, well, we already know this is right, so reduce it. All right. Which trig function is reciprocal to sine? CSC. What does CSC stand for? Just curious. No. What is CSC? What's it? It's an abbreviation. What is it abbreviation for? Cosecant. Cosecant, okay? So cosecant, if I already know what sine is, right, do I need to do all the math again? What do I need to do? We're just find a reciprocal. What was sine? 7/25. So what is cosecant? 25/7. All right. What was reciprocal to cosine? Secant. All right. So if I know that cosine was 24 over 25, then secant should be 25 over 24. And if I know that tangent was 7 over 24, then what's cotangent? All right. So could we prove we could show all the math, right? If we weren't given multiple choice options, could we write the correct ratios for all of these? Okay. All right. We didn't get into as much of this as I would have liked to, but you guys should be able to get a pretty decent start. Okay? And I'll answer questions tomorrow over things that we don't understand. Okay? Make sure to look into your examples. Specifically, it's going to talk about elevation and depression, some of those types of things. Question number D. Question number D doesn't give you a picture, or letter D doesn't give you a picture. You're going to want to look at example number 4 to be able to draw a picture so that you can identify all the different parts.